As much of the world switches over to electric transportation, the what about this and the what about that questions are popping up from those who are saying it's not possible. Now, on the other side of that discussion is Dr. Walter Mérida, who prefers to ask, what if? As in, what if there was a way to integrate all of the disparate urban infrastructure systems to create a cohesive, comprehensive, and connected platform driven by low or no carbon technologies? Dr. Mérida isn't just asking, he's doing. His labs, which are energy innovation hubs, have secured $23 million in public and private funding to convert a city-sized block on the UBC campus into a smart energy district. Now, the plan is to build an advanced solar array on top of a parking lot next to a substation. The parking lot will be retrofitted with bidirectional electrical vehicle charging stations. And what that means is these stations let vehicles pull in, plug in, and then send stored energy that's in the car into the grid, and then it can come back to them again later in the day. In other words, reversible EV charging. And reversible EVs mean that the passive energy that sits in the car when it's not being used could be used by active participants in a smart energy storage transaction. So additional electricity will be directed to an electrolyzer to split water into hydrogen and oxygen, supplying the refueling station for hydrogen fuel cell vehicles. And this hydrogen that's produced by this process is 100% renewable or green hydrogen. And that's what we want, green hydrogen. And then, because it's so complex, a secure 5G wireless technology platform will connect the system's components to each other and to other on-campus systems and assets for optimal productivity and efficiency. Already, you can see that it is complex and it takes time to understand. And to do so, I invited Dr. Walter Mérida to join me for a conversation that matters about the complex but achievable process of integrating renewable energy into the transportation and energy grid that we need to have and produce to successfully transition to electrified transportation. Dr. Mérida, thank you for joining me.
Thank you very much for the opportunity. It's great to be here.
You know, you just heard me read off what is your life's work. It is complex, isn't it? Mm-hmm. This idea that we can easily switch from, fossil fuel transportation to electric and meet the needs of all who want to use a vehicle requires some really careful thinking. How did you come up with this complex idea to start to pull these disparate ideas or components together?
Well, I think the basis of this is really the integration, as you described, of different systems. And if you think about it, the first feather that occurred in dinosaurs had nothing to do with flight. In the same way, I think we are experiencing the metamorphosis of cities. Urban assets are starting to become smart and interconnected, and they will be able to provide more than one service. But at the crux of this is really the links between chemical and electrical services. When people think about renewable or clean energy, most of the time we think about wind, solar, geothermal energy. What we are really saying is clean electricity. And yes, there are many services that we can provide with electricity, but there are some services that cannot be provided with electricity alone. And one good example is, for example, fast air travel. It's very difficult to envision a jetliner running on batteries from Frankfurt to Vancouver. And there are many other services, cement, steel production. The critical point is that we need chemical services as well as electrical services. And transportation is an interesting service because it can be provided with both at the moment. So you can have normal internal combustion engines and jet engines running on fossil fuels, but you're now seeing the penetration of electrical transportation. So hydrogen, the reason that hydrogen and hydrogen energy systems are so critical is that for the first time in the evolution of the energy system, you can now connect the great progress in renewable electricity, solar and wind, etc., to the chemical domain. And moving from electricity to hydrogen via electrolysis will enable this great progress in renewable electricity to start penetrating markets beyond transportation. So we are starting with transportation, but it's not the only service that we're going to address.
Okay, this connection between electric vehicles, solar panels, and so on to hydrogen is one that I had not contemplated before. And I know that the production of hydrogen requires a considerable amount of energy.
Correct.
So you need energy to produce it, but then it produces energy that it can put back into the system.
Right.
And so why in this loop? I drive in with my vehicle, I plug it in. I'm now feeding into that system, but that system is also then working
Correct.
a way to produce the energy that's going to come back and make sure that I can drive home at the end of the day.
Yes, and it has to do with the time at which you need the energy. If you think about cars and parking garages, they are two of the most underutilized assets anywhere in the world. At UBC, we have these parking buildings that fill up with cars at 9 a.m. and they stay full of cars for 8-9 hours a day, doing nothing but holding the cars. So the what-if question is, what if instead of just being passive assets, they became smart and connected to the rest of the infrastructure around them? And I'll give you a very simple example. If everyone came at 9 a.m. and plugged in their electric vehicle, we would have a spike in the demand for power. And for municipalities, this could mean that they will need to really consider retrofitting and renovation costs. But if you make the cars and the recharging infrastructure smart and you displace that charging, so you come in, but you don't necessarily start charging the car right away, and you displace the charging to 10 a.m., 11 a.m., you flatten that peak, and you avoid the cost of renovations and retrofits that will be required to just make the building itself capable of charging the vehicles. That's one piece of the part of the story. The other part of the story is that we are using solar energy and its connection to hydrogen as an example of a much broader challenge that renewable electricity has. And that is the challenge of intermittency. Mm-hmm. So when the sun is down or the wind is not blowing, you don't have that renewable electricity. So storage is a critical challenge for the energy system of the future. Once you convert green electrons from the photovoltaic cells into hydrogen, you have crossed to the chemical realm. And unlike electricity, which cannot be stored in large quantities economically, hydrogen can be stored in very large quantities. In fact, in some places in Europe, they are considering filling salt caverns, abandoned salt caverns, with hydrogen to provide seasonal energy storage. So it's not hours or weeks, it's months worth of energy storage.
And that fills the gap in the intermittent cycle especially with solar in a place like here, or wind.
Exactly.
Wow, okay. So how does the passive energy that sits in my car play into that equation? I understand taking it from the solar panel and we're going to now feed into that system. But you're saying, no, there's much more to this. Right. How does the vehicle play a part?
Well, if you think, in the example I gave you of the feather, the first feather was not meant for flight. The first car was not an advanced telecommunications center with large batteries on wheels, which is what cars now are. And each car, can be 50, 60, 80, 100 kilowatts, depending on the size of the vehicle. It doesn't take much to aggregate a significant power generation capacity in parking garages. So if we use a small percentage of the battery capacity in a large number of cars without additional significant investment, and this is the part that investors love, without significant additional investment, you have built a city-scale battery with assets that you had to build anyway or to buy anyway. Now, the challenge, the challenge is the storage and the intelligence that will be required to make the cars talk to the building and the building talk to the substations and the rest of the infrastructure. But that's where Canada has a great opportunity, because we are already leaders in hydrogen and other clean energy technologies. And as you may know, Vancouver is hosting the digital Canadian supercluster. So we have a great opportunity to be the innovators in the digital tools that will be required to manage these very complex systems. Very quickly, you realize that you need artificial intelligence and other tools to manage these very complex systems, because it's about connecting what, until recently anyway, had been completely disconnected assets, and transportation systems, civil infrastructure, and telecommunications networks. So, and the beauty of this, I think, is that new business models become possible, because as a car owner, well, why would you allow me to use your battery for energy transactions unless you get value out of that activity? Well, maybe you get a break in parking. You get maybe a better deal on parking, as long as we can use your vehicle for that energy transaction. And that's just the beginning, because as you know, UBC, the Vancouver campus of UBC, became the first 5G campus in Canada. And we recently flew the first 5G drone in Canada. And many of the questions that autonomous and connected vehicles need to answer in terms of safety, cybersecurity, reliability, and so on, can be answered with aerial autonomous vehicles as well. So once this platform is running, we will be able to connect the state of charge, the energy consumption, and the efficiency of hydrogen and electric vehicles to the rest of the built environment. And we can then start thinking not in terms of cars and roads and intersections, but in terms of smart cities that are truly connected and can be optimized, not just in terms of cost, but also in terms of greenhouse gas emissions or water use or other things that until now have been very difficult to introduce into the design of cities.
Okay, at the risk of sounding like I am a naysayer, which I'm not intending to be here, what are the challenges that you face to be able to bring, and I'm using your word here, these disparate systems together with different software, different manufacturers? Like, there isn't a program that was designed to say, oh yeah, in the future, you're going to be coming along and just hook you in here and we'll talk to one another and we'll make this work. How do you do it?
Well, the best thing you can do to get something done is to tell an engineer that it can't be done, because you will get it done. But to answer your question, many of the challenges are regulatory challenges. The codes and the standards required to build a refueling station, a hydrogen refueling station, or to operate these bidirectional large power transactions safely and efficiently are being developed right now. And cities in particular need to consider the rapidly changing technologies, because we may have in some sectors like electric vehicle infrastructure, for example, we may run into the VHS versus Betamax situation,
right,
where the cities and jurisdictions that are progressive and are early adopters of some technologies have to carefully plan their deployments. Otherwise, they run the risk of being locked into a technology or standard that may become obsolete. And I think this is one of the roles that universities can play, because we can provide a platform to develop these open standards and open systems that can be used by everyone.
So as you're talking about this, I go, okay, we developed the system in Vancouver, but what if they develop a different system in Seattle? Do we collectively have to start setting what becomes an international standard?
Absolutely. The short answer to that question is yes, we need to do that. And in some areas, we are doing that. So in terms of, for example, I haven't told you the next phase of the project, but there are some codes and standards being developed in terms of injecting hydrogen into the natural gas grid. Because if you think about it, as I mentioned before, one of the biggest challenges for renewable electricity is storage. Mm-hmm. Well, you could say, well, we could store electricity in batteries, but that's a big expense to just generate the batteries. But what if we generated green hydrogen by electrolysis and then injected it into the natural gas grid? And what you're doing when you do that is you're doing two things. One is you are diluting the carbon content of the natural gas,
right,
but at the same time, you have created a storage vessel for your electricity in the form of hydrogen that's already installed and is very, very large. But to answer your question, the other challenge is cost, because some of these technologies are not as well developed as other technologies, and the cost is still high. So the cost of electrolytic hydrogen is still quite high, $9, $12 a kilogram, depending the production cost. So again, this is one of the areas where universities and other research entities are working hard to reduce those costs and hopefully see the same cost reduction curves that we saw in the photovoltaic, solar energy, and wind energy realms.
I got hung up listening to you talking about injecting the hydrogen into methane or natural gas. Clearly, they must be compatible, because I would think, do they have a similar ignition point and energy return for you to be able to make that kind of blend?
Yes, the short answer is absolutely. I mean, there are some concerns or considerations that one needs to take into account in terms of the hydrogen molecule is a very small molecule and it tends to leak. So, much more than methane or other molecules which are a bit larger. But those problems are largely solved. In fact, in the north of England, they are already doing this, injecting hydrogen into the natural gas grid. And we have a couple of projects that are considering doing exactly that here in Canada as well.
And when you do that, of course, you reduce the amount of carbon that is the byproduct of burning methane or natural gas.
Yes.
So you've also delivered on another promise.
Exactly. And hydrogen, one of the beauties of hydrogen is that it doesn't contain carbon.
Right.
But it burns just like a normal fossil fuels would burn. So even if you burn hydrogen, which you can do in a jetliner, for example, you don't produce CO2. And you could envision not only that, but hydrogen is much lighter than jet fuel. So the planes can be larger and faster, and you can envision hypersonic flight from Frankfurt to Australia in less than 5 hours with zero carbon emissions. And that's where we are going. So this is what I mentioned, that the role of hydrogen in the global economy goes well beyond cars. I mean, that's one of the first applications, buses and trucks. But the other piece, and this is particularly important for British Columbia, about 39% of the greenhouse gas emissions in British Columbia come from transportation. And about half of those emissions come from heavy-duty vehicles, not passenger vehicles. So addressing the heavy-duty sector is incredibly important, and hydrogen is perfectly suited for that particular application. In fact, in Germany, they are already running trains on hydrogen.
So where are you at right now with, the renewable? Really, it's a test project at this point to prove that this works. Where are we at in making that happen? And as you move forward, what are the spin-off product and economic opportunities that exist here in BC with this kind of innovative thinking?
Right. So in terms of the schedule, we have already installed the EV charging infrastructure, and it will be fully operational by the end of the summer this year. The hydrogen refueling station is planned to start operations in the summer, more or less, of next year, 2022. And the solar array will be operational in October of 2022. So the site has been approved. We are moving into the construction phase. And at the moment, we are just preparing the right contracts and so on to get the construction started.
So as you develop each of those components, though, you're developing systems, software, and products that can become future Canadian and Vancouver-based companies.
Absolutely. The plan is to have a direct link to commercialization pathways. And we already have a couple of spin-off company ideas in the works. We are also developing the right partnerships to bring some of the right market development channels. Because beyond the domestic market, of course, Canada needs to consider the global markets.
Right.
The most immediate things, as I mentioned, may be on the software arena, because by necessity, we have to develop these tools anyway. But we have projects on hydrogen generation with advanced electrolysis and hydrogen generation with other technologies that are being developed right now.
Well, as we build it out, in some ways, I see what has happened in Silicon Valley for, software and computer development, or in the greater Seattle area, not just around computing sciences, but also aeronautics. You have somebody who comes along with a crystallizing idea, and it attracts other energy. And it's not just the energy that's being produced there, it's this kind of energy, which creates new ideas and fuels an economy as well.
Absolutely, and it creates a critical mass as well, because that's very important. And you're already seeing some very good developments. You probably saw the recent announcement of a multi-billion-dollar project in Alberta for hydrogen generation. Canada, I think, has been a leader in hydrogen technologies for quite a long time. And beyond hydrogen, the twin technology of carbon capture and sequestration is also going to become important as we look at decarbonizing our current energy system.
Right, and we already see that development underway up in Squamish.
That's correct. Yes.
And so the ability to help Mother Nature extract carbon from the environment, but to do it in a way that allows us to harness it and reuse it again, it's brilliant. And so
Yes.
This is, it's really encouraging, because one worries in British Columbia that we're so fossil fuel or resource based as an economy that will come to a dead end at some point. Whereas this is limitless.
Well, yes, if you look at the evolution of the energy system, since the Industrial Revolution. So in the Industrial Revolution used coal, then about 100 years later we moved to oil, and about 100 years later we saw the natural gas revolution with fracking and so on. And if you had let the energy system evolve on its own, we would naturally have evolved towards hydrogen and electricity, because hydrogen and electricity can provide all the energy services that you want without carbon emissions. The challenge, though, is that we don't have 100 years to make the transition. And the climate crisis has made it necessary to accelerate the innovation processes to get there faster.
Okay. So you talk about pulling together disparate systems to be able to move this forward quicker. Because I was doing some reading that said the transition from horse to automobile is the primary source of transportation in North America. That took more than 50 years.
Yes.
Even though everybody wanted a car, it took that long because you had to build the supply chains and build the cars and the support system and the highways and so on. We're doing something that's far more sophisticated than the building of the first car. Can we do it within an appropriate time range?
I am optimistic that we can. And I think since the Paris Agreement, if you look at the Paris Agreement, it was interesting because at the time, of course, it was a big political breakthrough. But at the same conference in Paris where that was announced, 3 other things happened which were very significant. So the first was the establishment of the Breakthrough Energy Coalition, which was a group of billionaires channeling funds to clean energy innovation. The government response to that was Mission Innovation, which is a similar effort from the government side. But the other thing that happened was Mark Carney, who was the chairman of the
Bank of Canada and Bank of England.
He's now running, he was running the Bank of England. He set up this task force for recommending that corporations disclose their climate exposure to climate risk. And that has now become legislation in the UK. So the movements that is creating in the financial sectors are liberating capital that is now looking for places to be placed in, and climate solutions are perfect for that because typically they require significant investment. So I am very optimistic that some of the commitments that we have made as a country as well are going to channel that energy and that creativity in the right way.
Well, and I recently hosted a 3-day workshop for the EU Commission and the Government of Canada saying, okay, how do we strengthen those connections between Canadian innovators and European innovators so that we can collectively keep moving in that same direction? And of course, we see the United States under the Biden administration moving rapidly now in that direction, whereas they were, they had the brakes on for a couple of years.
Yeah, and that provides a really nice way to link the countries in the activities, in different countries, because Canada has a national hydrogen mission, Australia has one, Germany has one. So that provides a very nice platform to find areas of common interest, not only for research and innovation, but for trade as well.
I'm out of time, but this is really exciting, and I'm hoping that you'll come back and maybe in a year or so and give us an update on all fronts.
Absolutely, we'll be happy to.
Wonderful. Thank you very much.
Thank you.
Yeah.